Hey, welcome back. Today we're going to talk more about directional derivatives, or what we call the gradient. Now, the gradient we talked about yesterday, this is our Dell. Let me write that better here. This is our Dell, upside down triangle, f of x, y. And we mentioned that the whole purpose of the gradient is to find the direction of greatest change. So, that is the purpose of our gradient. Now, to find the gradient of a multivariable function, we use the partial derivatives. Yesterday, again, we called this del f, and that's right up here. So if I have a function that has multiple variables, my del f of x, y, and no matter how many variables, will be just the vector comprised of all the partials, fx, fy, and so on and so forth. And this is what we call the gradient. So what this kind of means for us graphically is right down here. Up here we have this surface, and we are standing at this point. Down below here, we're given the gradient of the function. So this is our gradient right down here. Now remember, this is giving me the direction of our greatest change. So if I'm standing at the point, I will be heading in the same direction. But you got to remember, we can't really head in that direction because we would be in the surface. So what it does for us is it gives us on the surface itself. So if we had this direction on the surface, it's kind of hard to see that, but remember we're standing on the surface right here. This is going to be the direction of greatest change on our surface. And that's what we are looking for today. So again, let's just kind of revisit this. Del f, again, is the list of our partials of our function. We can use this gradient vector. It's a vector. It's also an operator. We're going to talk about that a little bit more too. Pronounce del f to find the rate of change of f by calculating its dot product with the unit vector. So the definition of our direction vector, and we talked about this in our last unit, all it says right here is we are taking our we are taking our del operator, dotting that with u. So in other words, we would say to get our directional vector, we talked about this the other day, we would just take our del operator, del f, and we would dot that with u. So let's talk about u for a little bit here. Remember, some properties of u, this is a unit vector. Now, what the unit vector does for us, this is going to give us the direction we want to head in. Now, be careful, del f will give us the direction in the greatest change. But if I want to find the change in any direction, I have to find u. I have to get my direction vector here. So what basically is where del, our gradient, finds the direction, give us the direction of the greatest ascent, this will give us our slope in any direction. So the unit vector gives us direction, and two, remember, this is giving me this is kind of giving me the slope. This is a slope right here. It gives me direction, and it gives me the slope, basically. Now, we have to multiply by 1. It has to be a unit vector, otherwise it changes the scale. And we talked about that in our last video. If we multiply by anything other than 1, like let's say my slope, remember direction vector gives us slope, if this was 2, it would be doubling our slope. So we want that to be 1 there. And again, looking at it over here, right over here, if this is my gradient down here, in the same direction, we get our maximum increase. So going in this direction, we get our maximum increase. So we also talked about, well, how do we then get our minimum increase? Well, to get the minimum increase, we go in the opposite direction. So the gradient f of a vector in the xy plane points in the direction of the maximum increase. If we want the minimum increase, we go in the opposite direction. And that should make sense. If this is the greatest slope in the greatest rate of change, then in the opposite direction, this would be my minimum, or my maximum, I guess I should say, maximum decrease. I guess I probably should say it that way instead of saying maximum increase. So I guess, all right. So some properties of Dell. One, if the gradient is 0, then if our gradient is 0, then our directional vector is going to be 0 for all of you as well, because that's just multiplication right there. This is 0. 0 times anything is 0. To get the direction of maximum increase, we look at DUF. This is our Dell. This is a vector. This is going to give us a vector if we plug in the number. And right here, so this is going to give us the direction. If I want to find the maximum value, we just look at the magnitude. This is the slope of the gradient. Now, if I want to find the direction of minimum increase, or maximum decrease, I guess, I don't know how we would, so we look at the opposite. Notice we go in the opposite direction. We're just changing our direction of Dell. To get the minimum, and then to find the, that should be the minimum value, it's looking at the magnitude of the gradient right there. So this is and we just change our sign to a negative. And that's all we're going to do there. All right, so go on to video number 2, and we're going to start taking a look at some examples.